Hello, good morning. My name is Chris. Full name is Christopher Aviso. And today I'm going to show and I'm going to videotape the step-by-step procedures in making programs for TrueTops or TrueLaser machine. Okay, so let's jump start. I'm going to open the TrueTops program on my desktop. Okay, there you are. The program is now loading the CAD application, the nesting application, the bending application, the punching application, and lastly, the laser application. Okay. So, before we start programming, make sure that you have already an AutoCAD design. Okay. In this case, we have a decorative design that used for the front doors, can be used also for windows, for fences and other decorative purposes. Okay. In this case, our customer is Cool Ornamental for Riyadh. Okay. So once you have the AutoCAD drawing, you should convert it into the DXF file because it's the file format that's being accepted by the TrueTops program. Okay, so prior to saving the DXF file, you have to explode first the whole design so that it will not conflict with the JO file. Okay, in this case, I've already exploded the parts. Okay, and this particular design is the one I'm going to create or I'm going to cut. Okay, so now we will start with the converting of DXF file into JO file. I'm going to open my folder Cool Ornamental, Cool. I'm going to choose 107, and this is the design that you have seen from the AutoCAD. Okay, in this case, I already converted the DXF file into JO file. Okay, so once you have already the JO file, which is the one utilized by the TrueTops program, we can now proceed to nesting. In the nesting we are going to open the nesting application. In the nesting application, the main purpose is to put the design into its appropriate sheet. Okay, in this case, our design, the length of our design is vertical dimension 2411.37, and the horizontal direction is 756 millimeter. Take note, we are using millimeter. Okay, so in this case, we're going to choose sheets that's longer than 2411.37 and wider than 756. Okay, the thickness of our design is 8 millimeter, so I'm going to choose 8 milli, and the material is mild steel. The size of the predefined sizes of the sheet. So in this case, I'm going to enlarge the material from 2440 to 25. And the width, which is 756, we can use also 800, which is, we have a standard size of 800 width of the sheets. Okay, then we're going to collect the part. Okay, we have successfully added one part, one design into the list. Then we're going to click OK. Okay, as you can see, there is a small picture of design or geometry that we have on the on the left upper part of our screen. Okay, I'm going to drag it down and then move the scroller so that it can fit into the sheet. Okay, once the design or the geo file turns to green, it means that it fit correctly to the sheet. Okay, I'm going to click yellow. So as you can see, there is no allowances from the edges of the sheets. Okay, in this case, I'm going to put a 10mm allowances all around the sheets so that it will not be damaged. Okay, I'm going to go to job. I'll go to job, then free geometry. Okay, the option, I'm going to put 10. So this means that the consistent sheet margin will become 10 milli from the edges. Okay, and the part distances, if it happens that you're going to have several geo file or geo designs, you can also put a universal distance of 10 milli. So it will become common. So right now, we're going to move our design so that we can have an allowance from the edge of the sheet. I'm going to pick the geo file, then go to parts, then to move, and then I'm going to move it freely. Okay, there we are. Now we have a 10mm allowance from the edge of the sheet. So our design is now safer from any kinds of defects coming from the manufacturing of the sheet, because we put it in the middle part. Okay, once we have successfully fitted the design into the sheets, then we're going to save now the nested part. Okay, I'm going to press simultaneously Ctrl S, and then as you can see, the file name is video trial. From the storage allocation, cool ornamental. Okay, it depends on the folder that you wanted to store the nested part, or in this case, the TAF file. I'll press OK. Then I'm going to overwrite because there is already an existing one. Okay, now we have successfully nested the design in the sheet. Okay. The next process after the CAD, after the nesting, we will proceed with the laser programming. Okay, so we're going to open the laser application. From the laser application, we have to open our TAF file. Okay, this one. This is the one that we have earlier. The video trial TAF. Okay, then I'm going to click OK. Then the first window that pops up is the technology table. Under the technology table, you have to choose which suitable technology table that you're going to use. So in this case, I'm going to use the uppermost. Since our material is mild steel, our gas will become oxygen. Okay, and the lens will become 7.5 inches. Okay, I'm going to choose this oxygen, and then from the process rule, I'm going to use the standard. If in case that the sheet has its cover or it has its top, normally for stainless there is a top sheets or top plastics that being placed, so that is to protect the sheets from scratches. So in this case, we're using mild steel. It's free from any plastics. Okay, so I'm going to use the process rule standard. Then I click OK, and then I will automatically process the part. Okay, as you can see, all of the geometric shapes